Warm greetings and good afternoon to everyone. Today I am going to give a numerical problem on thin cylindrical shell in this video lecture. So here a thin cylindrical shell which is of diameter 1000 millimeter, that is 1 meter diameter, and of thickness 5 mm is subjected to the internal fluid pressure of 10 Newton per square millimeter. The allowable stress in the material should not less than 1000 Newton per square millimeter. So for this cylindrical numerical problem, what about the hoof stresses and longitudinal stresses developed in the case of thin cylindrical shell or thin cylinders? And so what will be the longitudinal stress also developed in thin cylindrical shell? And what about the maximum shear stress developed in the case of thin cylindrical shell? So that is the unknown factors we have to find using this numerical problem. You know that the hoof stress or the circumferential stress developed in thin cylinders is given by F1, that is equal to the internal fluid pressure into the diameter divided by 2 times the thickness. So here, therefore F1 is equal to hoof stress, that is equal to PD by 2T. So therefore F1 is equal to, the pressure is 10 Newton per square millimeter into the diameter is 1000 divided by 2 times the thickness, so 2 into 5. So that is equal to, if you are simplifying it, you will get 1000 Newton per square millimeter. So this is the hoof stress or circumferential stress developed in the case of thin cylindrical shell. Similarly, what happened to the longitudinal stress developed? So here the longitudinal stress developed is given by F suffix 2, that is equal to PD by 4T. So that is nothing but half of the hoof stress. So it is equal to half of F1. You substitute the corresponding value of the pressure diameter divided by 4T. You will get 1000 into dP, pressure is 10 divided by 4 into 5. So you will get half of F1, that is equal to 1000 divided by 2, that is equal to 500 Newton per square millimeter. So the hoof stress is 1000 Newton per square millimeter and the longitudinal stress is 500 Newton per square millimeter. The worst stress is the hoof stress. So you have to stress and longitudinal stress, that is the thin cylindrical shell, you are analyzing it, you are not designing it. So once the hoof stress material value is given, you can find the thickness and also you can able to find the diameter if all the factors are given. So here we have found out the hoof stress F1 and the longitudinal stress F2. Now the maximum shear stress is Q max or tau max, that is equal to F1 minus F2 divided by 2. So what is the meaning of that? It is the average of the difference of the major and minor principal stress. So here the major principal stress is F1, that is hoof stress. The minor principal stress is the longitudinal stress F2. So therefore the tau max or Q max is equal to maximum shear stress, that is equal to 1000 minus 500 divided by 2. So that is 500 by 2, it is nothing but 250 MPa. That is, you know that 1 MPa is equal to 1 Newton per square millimeter. So therefore Q max is equal to 250 MPa or Newton per square millimeter. So this is how we are analyzing the thin cylindrical shell. Similarly, you can design the thin cylindrical shell if the material potential value is given, so that is the thickness should be greater than or equal to PD by 2F, where F is the allowable or the permissible shear, permissible stress in the case of thin cylinders or thin cylindrical shell. So if you are working out for the thickness, for example, we are getting for this problem of some minimum thickness of 4.5 mm. So here we have provided 5 mm so that the thickness is safe. So this is how the design, you have to go for the design. So if the internal fluid pressure and the allowable stress and also the diameter is given, you can find the thickness, that is cylindrical shell. So we have seen that we are going to see the design of thin cylindrical shell or cylinders in the next video lecture. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.